Hello once again for page 8 of the notes. This video is going to be a little bit longer because we're going to try to get through pages 8 and 9. So just bear with me, okay? But here we have a whole page to do this problem number 9. So here we have y double prime minus 5y prime plus 6y equals 2e to the 2t. So first thing we're going to do is we're going to solve the homogeneous version of this problem. So pretend there's a 0 over here. And that's going to help us find the complementary solution, right? So we have r squared minus 5r plus 6 equals 0. This is our characteristic equation. This factors as r minus 3, r minus 2 equals 0. And so r is 3, r is 2. And so that tells us that our complementary solution is c1 e to the 3t plus c2 e to the 2t. Okay? So let's just keep this where it is for now. Now we need to find a particular solution that'll solve the right-hand side, right? So our guess normally would be a e to the 2t. Now you'll notice that I left a little bit of room here, and maybe you can see why. Notice that a times e to the 2t as it is technically already represented in our complementary solution, right? But this is the right form. It's just that we already got one. So remember from the last video, what you do is you just hit it with a factor of t, right? And so instead of a e to the 2t, it's at e to the 2t, okay? And now we'll quickly run through these derivatives here. I'll leave them for you to verify. All right, so this one, yp prime, is a simple product rule. This one here, I'll leave for you to verify, but this, I mean, that's, yeah, I mean, there's an intermediate step here, so you should verify this. Take the time to actually verify this. All right, so now what that tells us then is that the right-hand side has to equal, well, it has to equal y double prime, so in this case yp double prime, minus 5 times yp prime, plus 6 times yp. And do the work. I'll just give you the answer. It's minus a e to the 2t. And so what that tells us is that the coefficient of e to the 2t over here has to be the same as the one over here. So 2 is negative a, and a is negative 2. Okay, good. So what that tells us then is yp equals minus 2t e to the 2t, right? Because remember our form for yp was right here, so I'm just filling in a equals negative 2. All right, so there's still a little bit left to this problem, but let's first start with the just y itself. That's yc, the complementary, plus yp, which now I think we have those pieces. So scrolling back up, this is c1 e to the 3t plus c2 e to the 2t minus 2t e to the 2t. All right. And now what we need to do is use the initial data to solve for c1 and c2. Right? So we're going to need y prime. So I'll leave this to verify. It is, okay. And so going back to the initial data, 5 is what I get when I plug in 0 into just y. So notice if I plug in 0 for t here, I get c1 plus c2, and now here I have a factor of 0, so that'll just go away. So I get 5 equals c1 plus c2, and 1 is what I get when I plug in 0 for t into y prime. And that's 3c1 plus 2c2 minus 2. Okay. And I'll just tell you what the answers are. C1 is negative 7, C2 is 12. You'll need to verify those on your own, but you're just solving a system of two equations with two unknowns. So it's pretty straightforward, I think. And therefore, we can now just find y, right? So plug in C1 equals negative 7 here. C2 is 12, and the particular has already been found. And there we go. All right, so let's move on to the next page and do the same thing. So now we have y double prime minus 6y prime plus 9y equals 2e to the 3t. So it's similar setup. First thing we're going to do is find the characteristic polynomial. We get r minus 3 squared, I think, which says that r equals 3, but we see that this is of multiplicity 2. Okay, so what that tells us is that yc has to be c1 e to the 3t plus c2. Well, we've already got an e to the 3t, so we throw a factor of t in front of it, right? Hopefully you're seeing how that works. Our guess for yp, well, let's see. I think you can kind of see where this is going to go. It should be of the form a e to the 3t, right? Because that's the form of our right-hand side. But we already have an a e to the 3t, right? It's right here. It's a constant times e to the 3t. So that means we need a variable t, right? Well, we already have one of those too, right? Look, we already have a constant times t e to the 3t. So in fact, to make it so that we're not repeating anything, we actually need a factor of t squared, right? And now you'll notice that this is not represented in our complementary at all, right? Yp prime is then the following, and yp double prime is, okay. So now that we have yp prime, and yp double prime, what that tells us is that 2e to the 3t has to equal, well, yp double prime minus 6 yp prime plus 9 times yp. I'll let you work all that out, but for the sake of time, I'll just tell you that it works out to be 2a times e to the 3t. So that's nice. And so now look, the coefficients need to match. So that means that 2 has to equal 2a, which says a equals 1. And so that tells us then that yp is just 1t squared e to the 3t. So now that we have yc and yp, we know therefore that y is the sum of those two, so c1 e to the 3t plus c2t e to the 3t plus t squared e to the 3t. And if we're going to apply our initial data here to solve the initial value problem, we're going to need y prime. Right? So y prime is, all right, so let's go back to the initial data. 1 is what I get when I plug in 0 into the function y, when I plug in 0 for t. So you'll notice plugging in 0, all I get is c1, right? When I plug in 0 here and here, both of those terms vanish. So I automatically get 1 equals c1, so that's easy. And 1 is also what I get when I plug in 0 into the function y prime. So I get 3 c1 plus c2. And you'll notice all of the others have a factor of t, so those all vanish when I plug in t equals 0. And so if c1 is 1, then c2 has to be minus 2. And so therefore y equals 1 times e to the 3t plus negative 2t e to the 3t plus t squared e to the 3t. So that's it for this video. In the next video, we'll finish pages 10 and 11 of the notes.